Hello everyone, welcome to Chapter 1, Module 1, Thinking Critically. My name is Robin Surf, and today we will be going over a few problems regarding different problems that we are going to think critically. So we are going to look at question 1, and we are given the digits 8, 10, 11, 12, 13 that equal 31. How do we determine what goes in the circles? We need to fill in the circles to equal 31. So what number would you choose to start with? I chose 8 to start with since it's the smallest number. It would be easier for me to add them together. We're going to be adding the numbers, and to check my work, what I had done is I plugged in 8 in the center, 13, 12, 10, and 11. So to check my work, I did 13 plus 8 plus 10 equals 31. I then went to 12 plus 8 plus 11, which also equals 31. The sum is what number? The sum is 31. So let's go ahead, and I had chose 3 solutions that we are going to look at. Let's look at the first solution. So the first solution is I had plugged in 10 in the center. As I checked my math, I did 8 plus 10 plus 12 equals 30, which does not equal the sum of 31. I also did 13 plus 10 plus 11, which equals 34. That also does not add up to 31. I then did, if you look in the center, I plugged in 13 in the center, and I did 8 plus 13 plus 10, and that equaled 31. But then when I did 11 plus 13 plus 12, what does that equal? That equaled 36. If you look all the way to the right, I had plugged in 12 in the center of the circle. And these are just different solutions that I'm showing you with the same numbers that do not work. That some do work and some do not work. So let's go ahead and look. As I check my own work, I did 13 plus 12 plus 11, which equals 36. So it's important for all of us to always make sure that we can back ourselves up with our answers and show our work as we did addition to find the sum. We are going to move on to part B, and we are going to look at the bottom of the page, and we're going to study this picture. So let's look at what numbers we have plugged in. And we have 2 on the left top, we have 8, we have 3, we have 5. So when we're looking at this diagram, how do we determine that the answer is 10? Well, how I had checked my math, we're going to do 2 plus 8 equals 10. And that's how we get our answer. We're going to do 5 plus 3 equals 8. And we are going to do 2 plus 5 equals 7. And the last one is 3 plus 8 equals 11. So let's go ahead and we are going to look above, and we have 1, 2, 3, and 4 problems that we are going to solve together. So let's go ahead and look at those. Are you able to complete the circles where the red arrow is pointing? So let's go ahead and look at number 1. 7 plus what number equals 15? Well, 8 plus 7 equals 15. That's how we got our answer. Let's go ahead and look at number 2. 6 plus what number equals 13? 7 plus 6 equals 13. Let's look at number 3, and the arrow is pointing to the top right corner. And 3 plus what number equals 8? 5. 5 plus 3 equals 8. Let's go ahead and look at the last number together. So we're looking at where the red arrow is on the bottom right corner. And we are going to do 8 plus what equals 18, and that answer is 10. In looking at the first picture, what will the answer be? In the bottom right-hand corner. And that answer is 12. We can go on and I can show you the different solutions, but these were the examples that we were going to do together. We are going to move on to question 2. What are the perimeters of each figure, which can be formed from the figures below? 9 square tiles are laid out on a table so that they make a solid pattern. Each tile must touch at least one other tile along an entire edge. See the 2 examples on the right. The squares all have sides of length 1. We are going to continue on question 2, and we are going to look at figure 1, 2, 3, and 4. The example shapes listed above are the varieties of ways the shapes can be formed, and there are 6 different ways to create the figure using the 1 times 1 squares. Each square is 1 unit. So let's go ahead and look at figure 1. How do you determine the perimeter of figure 1? What we are going to do is we are going to add up all the sides. So let's go ahead and add up the sides. Figure 1 has 12 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's go ahead and look at figure 2. We're going to count the number of sides on figure 2. We've got 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's go ahead and look at figure 3. How do you determine the perimeter of figure 3? And we are going to count the number of sides, and figure 3 has 20 sides. Let's go ahead and go down to figure 4. And how do you determine the perimeter of figure 4? We are going to count the number of sides. And figure 4 has 14 sides. So now we're going to look and at all of them. Which figure has the least perimeter and which figure has the greatest perimeter? So what we're going to do is you can see from the pictures that figure 1 has the least, while figure 3 and 4 have the greatest. Figure 1 has the least, which equals 12, and figure 3 and 2 have 20, which is the greatest. We are going to move on to question 3. So let's go ahead and look at the question. Are you able to complete the sequence of patterns from the dot images? So we're going to look at the dot images here. We're going to look at the first image to the left. How many dots were added to obtain the first figure? Well, we're going to look at the dots, and it says we only have 1, the first dot right there. How many dots were added to obtain to the second figure? Well, let's go ahead and we're going to look at the second one. And the second one has how many? 5. How many dots were added to obtain the third figure? So let's go ahead and look at the third one. And this one has 12. Can you list the sequence of numbers for each pattern? So we're going to look at the last one, and the number of dots for the fourth is 22. So we're simply just counting the dots in each pattern. Are you able to calculate the next 4 equations in the pattern? What you are going to do is you're adding 3 to each of the last numbers. So let's go ahead and look at our other example over here. And if we add 5, it looks like we are going to have 35 dots to the right in the first picture. And then the next pattern is we are going to have a total of 51. So how I checked my work is I had done 1 equals 1, 1 plus 4 equals 5, 1 plus 4 plus 7 equals 12, and 1 plus 4 plus 7 plus 10 equals 22. And that is how I checked my work as I counted the dots. Let's go ahead and look at the second one. And I did the same thing. So we're gonna do 1 plus 4 plus 7 plus 10 plus 13 equals 35. It's important to always check your math. So let's look at the last one. It is 1 plus 4 plus 7 plus 10 plus 13 plus 16, which equals 51. And that's how we counted our dots and got our answers. We are going to move on to question 4. And are you able to complete the blank squares? So we are going to look at our figures. We have figure 1, figure 2, and figure 3. What can we derive from the given information? Well, let's see. Each number is the sum of the two numbers immediately below. So let's go ahead and look in figure 1. The top number is the addition of the two numbers below it. So what I had done is, again, I like to check my math. And what we're going to do is we are going to add 7 plus 3 equals 10. And then we're going to do some subtraction. So we're going to take the top number and we're going to subtract that by 10, which equals 15. And when we get the number 15, we're going to subtract that by 7, which gives us x, which equals 8 in figure 1. In figure 2, we know that 1 plus 2y plus 2 equals 15. So therefore, we're going to do 3 plus 2y equals 15. We're looking at that top box, that top number. So 2y equals 12. And that leaves us with the missing number of 6. So y equals 6. Let's go ahead and look at figure 3. So again, we're going to look at all our possible numbers. We know that z plus x equals 27. We are calling the box next to z labeled as x. So the bottom box is labeled as y. We also know that x equals 9 plus y and z equals 2 plus y. So therefore, using z plus x equals 27. We're going to plug in those values. So we have parentheses 2 plus y plus parentheses 9 plus y, which equals that top number, which is 27. We're going to take 11 plus 2y, which equals 27, and that leaves us with y equals 8. So when we're looking at the figure 1, 2, and 3, they're all very similar. We just need to always remember to show our work. We're going to move on. And it looks like we have a graph. So we are going to study this graph. Can you determine who is married to who in the below chart? Well, the information that is provided for us is, I'm going to read you a little part about David, Will, Floyd, and Gus, Kitty, Sarah, Josie, and Ann. So we know that Floyd is Josie's brother. So we're going to go ahead and knock him out because we know that they are not married due to it is Josie's brother. So we are going to look. Josie and Gus dated some, but then Gus met his present wife. So I had already put an X that Gus and Josie are not married because it does tell us the information that they've dated some, but he has met his wife and he's married to somebody else. So let's move on. Kitty is married to Will. So we're going to put a check mark into our graph because they tell us that Kitty and Will are married. So if Kitty is married to Will, then what does this mean? She isn't married to anybody else. This also means none of the women are married to Will. So what are we going to do? We're going to go ahead and check off that David is not married to Kitty, Floyd is not married to Kitty, and Gus is not married to Kitty because they gave us the information that Kitty is married to Will. Since Josie is not married to Will, Floyd, or Gus, she must be married to who? Well, let's go ahead and look. We know that we can put an X in all these boxes for Sarah, Josie, and Ann because we know that Will is married to Kitty. Josie is married to David. Since Josie is not married to Will, Floyd, or Gus, she must be married to David. So we're going to go ahead and put a check mark where Josie and David is. Then we're going to put an X. David is not married to Sarah, and he is not married to Ann. So let's go ahead and move on. Since Floyd has a brother and Ann's husband is the only child, Ann's husband must be who? Well, with that information, we know that Gus is married to Ann since Floyd has a brother and Ann's husband is the only child. Ann's husband, that gives us the information that Floyd is not married to Ann. So let's move on. This gives us the information that the only person that is left was Floyd, so we put a check mark that he is married to Sarah. And at the end, we need to put that Gus is not married to Sarah. So that is how we figured out who is married to who. Question 6. We're going to look at the question. Are you able to complete a dot pattern and show how the dots in the representation of a trapezoid number are arranged into a rectangle with 2 or more columns than rows? So let's go ahead and look to the left, and we have some circles over here. Well, let's look at these circles. Consider the trapezoid numbers are 1 plus 1 plus 1 on the top. We're going to look in the middle, and we're going to consider the trapezoid numbers are 1 plus 2 plus 2 plus 2 plus 1. And down to the left, we're going to look at those, and we're going to consider the trapezoid numbers are 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. This type of number is simply a number that can be drawn using a series of dots which form a trapezoid. So we're going to look and notice in the beginning and ending of the formula, it starts with 1 plus 2 and 2 plus 1. So the numbers in between are considered, let's go ahead and look. And the numbers in between are considered to be n. If we look in the middle, so you can actually read the formula, and the formula reads 1 plus 2 plus n plus n plus n plus 2 plus 1. There are really 2 parts to this question. So what we are going to do is we just went through the formulas to make the trapezoid. So what we're going to do is each of the equations I'm pointing out here are considered to be the general formula for the nth trapezoid number. So we have 1 plus 1 plus 1 equals 3. So let's look at the general formula for this nth number. It equals 1 times 3. So now we are going into multiplication. Let's look at the second one. We're going to look at it, and we have 2 times 4 equals 8. And last, we're going to look at this multiplication, and to get 15, we're going to do 3 times 5. So when we are looking at all these formulas, we are going to move on and look at these dots. So can you show how the dots in the representation of the trapezoid number arranged into a rectangle with 2 more columns than rows? So from the previous slide, you began to use the 1 times 3, 2 times 4, 3 times 5, 4 times 6, 5 times 7, and etc. So let's go ahead and look at these. Are you able to tell from the circles how the diagrams are being formed? Well, let's go ahead and look. The second picture shows a 2 by 4 diagram. So you are going to count down, and there's only 2 circles in the middle. And then you're going to go to the right of the row, and you're going to count, and that tells us that there is 4. So that is how the second picture shows me that the diagram is 2 times 4. Let's go ahead and look at the third picture, and this shows we have 3, 1, 2, 3 times 5. We're going to count across 1, 2, 3, 4, 5. And that shows us that we are having 3 times 5 in our diagram. The last picture shows what a 4 by 6 diagram looks like. So again, we're going to count 1, 2, 3, 4 down and across 1, 2, 3, 4, 5, 6. Do you notice also what shape the circles make? Well, this is how the rectangles are formed by the dots. So all you need to do is we're going to look at the first one, and we have 3. So 1, 2, 3 across, which when we turn this formula into multiplication, we're going to do 1 times 3. Let's look at the second one. Again, we just went over this one. We have 2, and then we're going to count across 1, 2, 3, 4. Next one, 3 times 5, 4 times 6.